Hey everyone, this is a quick video for us to go over, learn, or review how to work with something called one variable inequality. Sorry, it's a little cut off on my little note sheet over here. When we're solving one variable inequalities, we would also like to graph one variable inequalities. The way we're going to graph these is on a number line. Inequalities have symbols like less than, greater than, less than or equal to, and greater than or equal to. I think I said all four of them. Sorry if I mixed them up. Then we're also going to use something called interval notation. We're going to learn the difference between open and closed points, intervals. We're going to learn the difference between when to use parentheses and when to use a squared bracket. We're going to over when to flip the inequality symbol, and we're going to talk about absolute value inequalities, okay? So these are probably things you did cover in Algebra 1 to an extent, but we are going to kind of build on them. So let's warm up with the inequalities up here. You need to write small and neat because you just want to fit the most important information over here, okay? There is going to be some stuff that I will be adding down to the bottom, so all of your really important notes are in one place. So make sure we take our time and stay organized, okay? So example 1, the first thing I'm going to do is solve this one variable inequality. It's one variable because I only have x in it. Sometimes you've seen inequalities that have x's and y's in them, and we graph them on the xy plane, and we end up shading on one side of the line or whatever that graph is. So here I want to get the x alone. I'm going to start by adding 10 to both sides. That will give me, in my next step, 3x alone, because I add 10 to negative 10 and get 0, less than or equal to 45. Then, to continue getting the x alone, it's attached by multiplication, so I will divide. Inverse operation, inverse, not opposite, okay? Inverse operation, that reduces, it does not cancel, it reduces, becomes a 1, and then I'm left with x is less than or equal to, you gotta know your times tables quickly, that should be 15. So step 1, we're gonna solve the inequality. Now, we're going to graph it. When we ask you to graph an inequality, if there's only one variable, there's only one number line. I'm only going to put a tick mark on it to represent the number in the problem. So I'm only going to go ahead and label 15. I'm actually going to label it above to leave more room underneath for our other writing. Now, it's less than or equal to. That is how we read that symbol. From the x, if you're at that pointy side, okay, you go x is less than or equal to that number. All right. I'm going to draw an open circle here. I'm not going to be a weenie about it. I'm going to draw a pretty decent sized circle. And if it's less than 15, which way is less? Think of a number line. Here, I would go 15, 16, 17, 18. Here, 14, 13, 12. The less than side is where the numbers are smaller, so that's this side over here. And it goes on forever. It doesn't tell me I should stop. And it could be equal to 15, so I'm going to make no question about it, and I'm going to color in that point. So there we have it. That is the graph of the inequality. Not so bad. Finished. We just take our time to make our graph. So this right here is the solved inequality right there, and this over here is the graph on a number line indicating our, what we call a solution set. So these are all of the places where x can be. X can be here, x can be here, x can be here. Whatever x is, it can be in any of the places that are colored with the pink highlighter. One last thing we're going to do is something called interval notation. We're going to learn by example, or maybe you're just reviewing. We go from left to right to describe it. All the way at the left, what is this arrow pointing at? If that's 15 and we go forever that way, the smallest thing we're dealing with is something called negative infinity. When you can never reach a certain number, we use a parenthesis on it. Since you can't actually get to infinity, it's a concept, not really a number, not really a set location, we're going to use a parenthesis again. Parentheses when you don't actually get to that number or place. Comma. This comma is not an ordered pair comma. This comma is not in like a list of names or a list of things. It's saying from negative infinity until, so I start at negative infinity and I keep going until 15. So 15 is where I stop. Now I can get to 15. It's colored in. We call this closed. It's equal to. That symbol I use for this then will not be a parenthesis. It is a closed square bracket, okay? So I'm going to draw a little arrow. I'm going to label that square bracket. So if you have to say it out loud, that's what I say in class for us. And another word I might use for this point is closed, because it's equal to. You may see in the future, so I added notes for example 1, something like this, where the 15 is labeled, all right? And maybe it's hardly even colored. Some graphs are not so well done, okay? Be a little bit more discreet. I'm a little bit extra, sorry. And that's really the same thing, and it helps us kind of picture the bracket being used in the final answer, okay? Maybe press pause and try this one by yourself, and then come back when you're ready. Next, I'm going to subtract 5 from both sides, so that's 7x is less than 4. Then I'm going to divide both sides by 7, so x is less than 4 over 7. Go ahead and draw my number line. Only tick mark I need is 4 over 7. I'm going to put a big open circle there. Which way am I shading? X is less than 4 over 7, so again, I'm still going this way. Okay, now it's not or equal to, so I will not color that circle in, okay? So what are we gonna do? Let's see. Interval notation, I'm still coming from negative infinity. Same idea as that one, okay? Compare them, how are they similar? Comma, comma, you say where you go until. I'm going until 4/7. Now I did use a square before because it was closed. I was able to get there. The parenthesis I mentioned for the infinity or negative infinity is because you don't get there. Do I get to 4/7? No, I get right up against it. You cannot define the number that is just under 4/7 because numbers are infinite. So we say 4/7 here, and we're going to draw a parenthesis. There's your interval notation. There's your graph. There's your inequality. Inequality, graph, and sorry, the interval notation's a little ugly, but interval notation right there. Other notes that I might do, those are parentheses, not a square bracket. That I think you know. But then we call this open. Okay, when it's not included, open. Maybe on a number line, someone else might graph it like this: a big parenthesis. Clearly define which one it is. Don't make it a guessing game. 4/7, and then maybe a little discreetly shade it over here, and we're done. Okay, so I'm going to skip this one because I want you to try this one on your own. I'm going to skip this one because I think it's a little easier than this one. I'm going to do this one right now, and we'll chat about that, okay? So you will do that, and you could do the 6 and 7 on your own, okay? It just has the word or in the middle instead of being compound in this way. So these are compound inequalities. So when you want to get x alone in an example like this one, you want to go about doing that by using, you treat everything the same, you use same algebra steps, but we're going to, in this case, subtract 10 from 3 places. So minus 10, minus 10, minus 10. All right, the inequalities separate like the boundaries, okay? Start there. 25 minus 10 is 15 is less than negative 7x is less than 81. Now, one of the things on our list of things to do is when to flip the inequality. Here's where it happens. So maybe notes on example 5 will be you must flip the inequality when you divide, but division is really the same as what? Multiplication. Or multiply both sides by a negative number. Okay? Very important. That's a T, sorry. Okay, so I'm dividing by -7. Another thing that you guys have to get used to is you don't need decimals, and you definitely don't want to deal with mixed numbers. Just leave your improper fractions alone. So from this step, I'm going to have x in the middle. That reduced to a 1. That flipped this way. I'm going to pull the negative up to my numerator, -81/7. Flipping this, pull the negative up, -15/7. Now, which number is smaller? -15/7 or -81/7? Pretend they weren't negative. Okay, let's pretend this is a 7th, this little dog. Someone has 15 of them, 15/7. Somebody else has 81 of them, 81/7. Well, who has more? The person who has 81/7. They have more. But when you make them negative, that just makes it more negative. So when we draw our number line, we'll have 2 tick marks instead of 1. My more leftmost tick mark is going to be -81/7, and the tick mark to the right is -15/7. Don't be a weenie about it. Big open circles so that we know it's colored. Now think about it. You have to read these carefully. There is a major disconnect with this. From the x, x is greater than -81/7. There's -81/7. X is greater than it. That means I'm going toward this side, okay? When you read this way, it says, this is where everyone messes up. X is less than, pointy side, x is less than -15/7. That's this side, okay? Too many of you are messing that up. So the middle is colored, and just the middle. These are open, they're not colored in. Interval notation, and make sure when you try these others on your own, compare it to the examples we have. My interval notation, I do not include the infinities this time. These are not included. So what will I have? Not included, parenthesis, -81/7, comma, until. When do I go until? -15/7, close the parentheses. So that is my interval notation answer. It looks like an ordered pair. It is not. You would need to use context clues. That is my graph. This is it's a compound inequality. Okay? You have to rewind it and watch it again now that you have it written, then you do that. Okay? This over here, I know I said I wasn't going to, but I'm going to just chat about it a little bit. Hopefully I do not end up doing the whole thing. So over here, if I solve this, the word or stays in the middle the whole time, okay? Divide by 2 on both sides, I get x is greater than 4, so that's one piece of criteria. Or, so x has to be greater than 4, or, subtract 4, x is less than -3. It could be one or the other. It could be both, but it doesn't need to be both. Here, that says and, it has to be an and, two things at the same time. This is essentially an and. I'm less than -15/7 and greater than -81/7. How do you do both at the same time? Right there in the middle. So, number line, who's smaller? -3. This one over here, -4. Don't be a weenie, big circles right there. They're gonna be open, and then carefully think about the shading. X is greater, it should be a +4, sorry. X is greater than 4 or less than -3. There we go. So much for not doing the whole example. Interval notation. This side compares to that first example before. Parentheses, negative infinity, comma. Now where do I go from here? Negative infinity, comma, -3, parenthesis, not included. Now I have a gap. You could just start another parenthesis and say now 4, comma, infinity, because we go to the right forever. However, we have a symbol. We use something called a union symbol. So this symbol, it looks like a little horseshoe. That means union, and it unites two things together. It's our union symbol. So we just happen to have two intervals. This is called interval notation. You just happen to have two intervals in this situation, okay? So take your time, look through them, redo the same examples, okay? Do them again in your notebook paper. Then try example 3, example 4, and example 7. Example 7 and, okay? Do not worry about those yet, unless you remember absolute value inequalities. So we can save those. I'm going to actually add one more example for your assignment, okay? Because I want another or example, so extra. So I'm going to call this one like example 6. So let's just do 3x minus 5 is greater than 10. So, or negative x over 2 is greater than let's do 1. I'm not going to go too crazy. Make it a 1. Okay, so this is like example 6. We're going to solve it, keep the word or in the middle the whole time. So up here, my interval notation answer is that. My number line answer, my graph is that. And my inequality answer is that. So we want to find those three things. If you look, I did that for all of the examples, all right? All of those examples, everything's done. I just didn't really circle this, but here it is, okay? My interval notation, and that one's circled there, okay? Hopefully that helps. So again, I want you guys to work on example 3, example 4, example 7, and this one down on the bottom, which is like example 6, okay? After that's all done, just check on Google Classroom for any extra assignments so we can get lots of grades in. Maybe I'll give you guys a little simple quizzes on inequalities or a little quizzes on interval notation so that you guys can get used to the notation and the symbols. When to use a parenthesis, when it's open, when to use a bracket, when infinity happens, things like that. So let's do our best. Make sure everyone has notes on this. So I will check your notes for a classwork grade, and I will also check that you did the assignment. Thank you. Good luck.